So we look at whether a result is real or just a random chance of a difference. There's a new hand washing protocol at Pompey Hospital, and after introducing the new hand washing protocol, the hospital in Pompey tracked surgical site infections for 2 months. They found the infection rate dropped from 6% to 3% and a reported p value of 0.04. The director declared our program works. The p-value proves it. This presumes some knowledge of what a p-value is. And so we'll go ahead and here, for those of you who are in this course watching this video, you can go back to your home page, Introduction to Statistics, textbook, and pop open this drawer and come down to chapter 10. And in section 10.3, scroll down, the p-value is covered. The p-value is a calculation of the area beyond a t-statistic. We'll set that aside. Uh, the modern interpretation of the p-value is only to inform one whether a result is surprising or not, and that is surprising less than a predetermined value. A value often referred to as alpha, but is your risk of a type 1 error. You can't have a zero risk of a type 1 false positive. You have to accept some level of a false positive occurring. And so in many fields, 0.05 is the traditionally used value for a alpha, for a risk of a zero point 0.5 per risk of a false positive. And the way it works is we're surprised if the p-value is less than 0.05. It means it's surprising. The distance of the sample means is surprisingly large and large enough to be statistically significant. Surprising means we reject the null hypothesis. If the p-value is larger than 0.05, it's not surprising, and we fail to reject the null hypothesis. Down below, I'll share a link to a statistics video I've done on the p-value that you can view to get some more details on it and how it's calculated in this MS 150 statistics class. I'll also add a link to the textbook outside of Moodle, so those who are working outside of Moodle can get at this same material. And we won't worry too much about the functions for calculating the p-value, but uh, the p-value has some strong caveats. The p-value does not tell you the probability that that the null hypothesis is correct, that we shouldn't reject it. Um, that doesn't do that. Um, we don't have a certain percentage. P-values only indicate how incompatible the data are with a specified statistical model. They don't measure the probability that the studied hypothesis is true, or that the probability was produced by random chance alone. Scientific conclusions of business policies should not be based on whether a p-value passes a specific threshold. And this is the American Statistical Association March 2016 uh, conference on trying to decide what the p-value should mean. Proper inference reporting requires transparency, full, and a p-value does not measure the size of the effect or the importance of a result. That's a key difficulty with it. The effect may be so small that it's ultimately meaningless. Uh, and so, even though it's significant, it doesn't have any useful application in the real world. If somebody says, you normally get over a cold in 7 days, but I have a medicine that that improves it such that you get over it in 6.8 days and it's significant, zero point 0.2 days isn't the difference for a cold. Uh, it just isn't. That's a few hours difference. It may be significant, but it's not meaningful to a cold sufferer. By itself, a p-value does not provide a good measure of evidence regarding a model hypothesis. And there's a number of links to further information on this. And so the p-value, the way I treat it is, should you be surprised or not? And once you're surprised, Then you can calculate the effect size and see whether it's small, medium, or large. The effect size is how big is this difference relative to the standard deviation, the variation seen in the data. Technically, the pooled standard deviation, but that's beyond the scope of this introduction to the concepts of medical statistics. So that p-value only tells us how surprised we should be. Uh, and it is an area that many it's been unfortunately this it's been somewhat abused because sometimes people study multiple variables and then look for any variable that caused a p-value to go below 0.05 and publish a result that they found something significant. And that's that's a misuse of the p-value. You can't do that with the p-value. That's called p-hacking. And if you try to use, if you do have multiple variables that you're testing, then you have to correct the p-value using one of the various, either Bonferroni or other corrections. You have to reduce it basically. If you do 20 tests, you've got to reduce the p-value by a factor of 20 in a Bonferroni test. And then the textbook has some examples applicable to the statistics class. But the p-value takes a look at, say you have two means, two different averages, or two different percentages, and tells you whether or not it's surprisingly different or not surprisingly different. And that's about all you can say about the p-value uh, in this case. It doesn't tell you how big the effect size is and whether it's a large effect. Um, and certainly the when when one has a very small effect size, you may be looking at something else driving the system, even though you had a significant result of the p-value. So p-values don't prove anything. They really only tell you if you should be surprised, and at that point you need to do further investigation to take a look at how big is the effect size. Now, confidence intervals are a related concept, and modern statistics goes back to using confidence levels, um, confidence intervals. They estimate the range in which a particular value might be found. And that's in the book too. If you go back to chapter 9, that whole chapter is on confidence intervals. And many studies today cite confidence intervals rather than p-values because they give you a range in which you expect to find a population mean. And then if that population mean is outside that range, then you can say it's surprising. But it gives you a bit a better picture of how uncertain one is about a particular result because it quotes a range, not a single p-value. And once it's significant, then yes, you can go ahead and do an effect size from 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 this. Chapter 10.1 uses confidence intervals to do hypothesis testing, which is a currently recommended procedure um, in many fields. They know they've moved away from using p-values and moved towards using confidence intervals to do hypothesis testing. Uh, and so that's been a more modern take on this situation. So the textbook has some information on this. The video, which I'll link below, has some information on this. Take a look at this week and uh, uh, we answer the guiding questions uh, in the Moodle assignment. Thanks for watching.